take questions through the questions bar. So if you have any questions throughout the webinar, you can just type them in and we'll pause occasionally to address them. So don't wait until breaks. You can just enter them whenever you have a question. And we will address them as we go. Next slide. Okay, so this webinar is sponsored by PG&E, and both California Multifamily New Homes and California Advanced Homes Program are run by PG&E funds. These are ratepayer funded programs, so we encourage you to take advantage of them. Next slide. Great, so quick overview of the programs. Both California Advanced Homes Program and California Multifamily New Homes are currently operating. These are new construction, design assistance, and incentive programs intended to promote energy efficiency, zero net energy. Both programs provide funds to help offset the cost of increased energy efficiency at your projects. The programs have the goal of helping homes and multifamily apartments and townhomes and such to reach zero net energy by 2020. So that is California's goal for new construction projects, new construction residential projects. Funding is limited and can change, especially California Multifamily New Homes Program. We're actually up against a deadline. So if you are interested in learning more, they'll actually have a survey that comes up at the end of this webinar, and you can indicate whether you'd like us to follow up with you. We are currently taking applications. And I should say too, so this webinar actually came about through an initiative we're calling the California Advanced Homes Program Master Builder Initiative, which is a special sub-program of California Advanced Homes aimed at helping single-family home builders to prepare for the 2016 standards, which includes increased efficiency to the wall system, which we'll be discussing today. Next slide. So just one upcoming event we will be present at, actually we'll be at a few events, but a big one is the Monterey Design Conference in Pacific Grove. So if you are attending, I would be happy to meet with you in person. So feel free to give us an email and we can schedule some time to touch base. Next slide. Okay, so we're ready to introduce our panelists. We're very fortunate to have David Heslin with Earth Advantage. So he's the executive director at Earth Advantage, which is an Oregon nonprofit that works to provide certification and education services to building professionals. David operated his own green building firm from 1999 to 2008. During that time, he built with a variety of advanced building techniques, especially advanced wall systems. Those projects included pioneering homes such as NAHB's 2003 Green Custom Home of the Year to the Net Zero Water House in the San Juan Islands in 2010, and the first Net Zero Energy House in Portland in 2014. So David will be presenting the bulk of the presentation today, and we have some fun poll questions that we'll be breaking up with, and so it should be a really interesting webinar. We will be distributing the slide deck and the recording to everybody after the presentation. So look forward to that. And without further ado, I will transition over to David. Thanks, David.
Thank you, Shannon. Really appreciate that. And you know, I wish that net zero project I did in Portland was in 2014 because it would have been a lot easier. It was actually back in 2004 when we didn't have quite as good a planning tools. We hadn't tested out quite as many assemblies back then, and solar cost a whole lot more back then as well. But I did move over from the contracting world, where I worked for 15 years, to work at the nonprofit in the 2008-2009 timeframe, and I was lucky enough to work on a lot of houses with a lot of different assemblies, but wall systems, we sort of tried the gamut in the late 90s through the early 2000s. From ICF systems to SIP systems to double stud walls to exterior foam, interior strapping, a whole variety of things, trying to find out what would work best for energy efficiency, what was the most cost efficient, and what could handle moisture issues the best. And now I'm lucky enough to work at a place like Earth Advantage. It's similar to Build It Green in that we do certifications for our market, but we also have really in-depth training classes for designers and builders as well. So today we're really focusing on walls, and we're going to go over several different wall assemblies that'll meet the new code requirements in California, and then also talk about how they handle moisture, both interior and exterior. And then we do have some cost comparison information that's been developed from studies that is at least should be indicative for you. Every market is a little different, but it should give you some first indications about things. So what we're really hoping you walk away from today is understanding which assemblies are going to meet the U-factor limits that are going to be required under the new code, and also get into details about what it's going to take for you to implement these new wall systems in your projects. While at the same time, when you do add more layers of insulation, there is the possibility of creating moisture problems that you didn't have before, because you're changing the temperature of materials within this assembly, and that does lead to the possibility for moisture problems. So we're going to take a quick dive into that. We obviously don't have time today to go into real detail on the building science, but we will look at it a little bit. So let's quickly go into what the standards are, and then what some of the different assembly options are that we're going to be looking at. So the comparison that we're looking at is that the maximum U factor is changing from 0.065 to a 0.051 for walls in all climate zones in California, except zones 6 and 7 that form that narrow band along the Southern California coast. So to get to that level, that means these higher efficiency walls, will need to be higher levels of insulation. And it's pretty straightforward that you can either accomplish that by increasing the overall wall thickness with wall framing, or increasing the thickness of rigid wall insulation that gets applied on the exterior of the wall. So, the different ways that handle this have different cost implications, because the materials that have higher R value per inch also tend to be more expensive. So, what I experienced and what advanced builders in your market and our market have experienced is they're always finding themselves, what's the right balance between reaching these greater thicknesses to achieve the R values, and what's the cost of the increased insulation. So that best balance is going to vary for any given project, depending on material and labor costs in your market, also on the design of the building that you have. And there are other factors to consider, like the tradespeople that are working on your jobs, especially as regards to what the exterior finishes of the project are going to be. So, as most of you know, builders are reluctant to adopt new systems, and especially because it may lead to unexpected problems with materials or workmanship, and that delays and extra costs are something that every builder is trying to minimize the risk of. So moving to new products and materials can lead to these problems, but getting a start like our conversation today can start identifying where those problems might exist, so you can start thinking through and looking for the opportunities to get ahead and avoid those problems. But builders across the country and across the world are evolving their methods to change wall systems, because it is one of the key areas that still exists for us to increase building energy efficiency. So actually, let's do that polling question now, Shannon. The first polling question, if you could put that up. And then you could just let me know.
Yes. Sorry, I was muted. So we have 3 questions that looks like most folks have answered. The question is, have you implemented 2x6 wall assemblies at any of your projects? And I will now wrap up the poll. And David, I'll read you the answers, but I'm curious how you think that folks may have responded. Either that it's their standard practice, or maybe they haven't done it yet. What do you think the options are, or what do you think people have responded?
I'm not sure who exactly is on the phone, but I'm going to give the benefit of the doubt and say, at least 75% have tried it. So
yeah, I think you're actually right. 49% yes, this is our standard practice. 31%. We have experimented with 2x6 walls, and 20% is no, but we would like to learn more. I like to assume that folks are on this webinar because they are curious to learn more. So let me just, I can share that with
Great.
folks, and then we'll move on.
All right. Thanks, everybody, for doing that. That gives me a much better idea. And I think you all will learn from looking at this chart that what we need to achieve now is this new lower U value. You can see which wall systems actually achieve that value. They should all be highlighted for you now. And as you can tell, most of them are 2x6 framed walls. It is still possible to hit these values with a 2x4 wall in some instances, but that requires R8 exterior insulation. So most of the time, folks are going to be building 2x6 walls in order to attain the performance that's needed for the new code. So we're going to just review the most likely walls that we think you're going to be using out there in your projects, and just give you some a little discussion about the pros and cons of each different assembly type. So zeroing in on this type, you're talking about all these are 2x6 walls, either having the stud spacing at 24 inches on center or 16 inches on center, except for there's a 2x4 wall at the bottom that has the 16 inches on center with R15 in the cavity and R8 on the exterior of the system. So the trade-offs when you're thinking about if you wanted to remain with 2x4 as your standard practice, using an R8 on the outside of your building is thicker than is standardly used with a synthetic stucco application. So there may be issues with your siding contractor and their material supplier about moving to that type of a system. versus when you're looking at the top three and you only need 1 to 1¼ inches of foam to meet the requirement. That's easily met with most of your stucco systems, synthetic stucco systems that are currently being used. So the details of really thinking about, for any different system, there are advantages and disadvantages of that system. But to help builders identify the right balance, you need to look at each system and sort of rate them about if the system provides you an advantage or a disadvantage. And choosing the best system for each individual builder and project is basically a pro versus con exercise for you. So planning, for instance, is going to be a requirement that gets into if you have thicker walls, how do you handle dimension changes on your plan, especially trades coordination. I know this caused some troubles here when we moved to 2x6 walls back in 1993 in the Pacific Northwest. And initially this was causing trouble with a lot of the plumbers out there until it was really handled better when they were coming in to do their subfloor plumbing installation. Good planning and clear measurements on the plans really helped avoid problems that you got going early. When we look further down in the lower left quadrant of this slide, we're talking about if you're moving to greater thicknesses of foam insulation on the outside, trying to ensure that you're keeping a quality look to the siding, because you might be getting a greater differential in the surface of the siding material with the thicker foams applied to that. And another key element for us that we've discovered over the years is on the cavity insulation quality. When you move to the 2x6 batts and ensuring that there's a quality fit within all the wall cavities can have a great impact on whether or not you're actually getting the benefit of the added cavity insulation or not. Because if you don't have properly installed batts, the greater thickness is not really reaching its full potential on the project. So let's go through some of the options in more detail then. So for instance, if you are moving to 2x6 framing using an advanced framing technique of being your studs at 24 inches on center, but using the lower density R19 batts, you can use an R4 exterior foam insulation and you'll reach code. So the benefits from this on the siding standpoint is that you're using the thinner foam on the outside. So if you were to use a clad siding, it's simpler to do that with a thinner exterior foam than it is to do with a thicker exterior foam. Also, your air sealing is typical to what it normally would be in this situation, and your weather barrier details are going to be relatively standard for what your builders are already doing today, as is the water vapor control. Those are the main benefits of that assembly. Now, if you're keeping your studs spaced at 16 inches on center, then you're going to have to bump up. And so if you move your studs to 16 inches on center and you're still only putting an inch of foam on the outside, you have to increase the cavity insulation to an R21. So this basically has the same pros and cons, but it's more about if your builder doesn't feel comfortable with 24 inches on center studs, they're going to have to take, and they're only using R4 on the outside, they're going to have to take the cavity insulation to R21. Now, if you're at a a 2x6 framing that's at 16 inches on center, and you don't want to make the move to the R21 insulation in the cavity, and you want to stay with R19, then you're going to have to bump up your exterior insulation to reach R6, which is typically going to take you to at least 1.25 inches if you're using your exterior foam that has higher insulation per value per inch. So these are the costs and benefits that start to weigh back and forth. And here you can see that we no longer had an advantage on the furring details, siding and trim, and cavity insulation quality for this assembly due to the fact that you are going to move to a thicker exterior foam on this assembly. Now, if you do have a builder that wants to stay with 2x4 framing for various reasons, now you're looking at probably staying at 16 inches on center as well. With the R15 cavity insulation, you're going to have to go all the way up to an R8 on the outside in order to meet the U value that is required by code. For those builders that might want to try this, they don't really have to change much on the planning side, but the real issue for them is going to be how are they going to deal with utilizing the 2 inches of foam on the outside of the wall and the issues that's going to raise for them around siding. There are a couple other assemblies that we just wanted to show you that do get used. I'm not sure how often they might have been used in your market, but for instance, this staggered stud wall is what I used on that net zero home back in 2004. And this is a staggered stud on a 2x8 plate, which is would provide enough of R value to be a wall that would pass in the new code. The advantages here, I would say that the primary advantage is if you have a builder that does not use exterior foam typically on their buildings, that the weather barrier details are going to be very easy to take care of with this system. And that also, if you do want to reach even higher levels of insulation, as is indicated at the bottom with the super insulation consideration, this is a very easy way to attain this, as you can create thicker and thicker walls if you move to this type of assembly and have it really not changed the way you build otherwise. The greenhouse gas advantage at the bottom is simply indicating that with this type of system you don't have to use any exterior foam in your wall assembly. This can be done with cellulose or fiberglass insulation, and therefore the embodied energy of the materials is lower using this type of a system. A double stud wall is similar to the staggered stud, except you actually do have 2 sets of bottom plates and top plates. So this allows, this is what you see on passive house projects pretty commonly, and where they're going for really high R value assemblies. And then one key element is that you do have to apply a rigid material, typically plywood, above the top plate that acts as an air barrier, fire stop, and also ties the 2 walls together. So advantages of this are very similar to the advantages on the stagger stud system, except I would say, from a super insulation standpoint, you can even go further with this assembly. Then one last option to tell you about, which is something that's just been used on a few projects here in the Northwest and is now starting to be adopted on a few more projects. And this, in this assembly, instead of putting the rigid foam insulation outside of your wall sheathing, the rigid insulation is actually placed between the wall sheathing and the face of the studs. So a few advantages of this: it allows your weather resistant barrier and all the details for that on the surface of your sheathing to be done in a very standard way. An additional advantage that has been discovered by testing at Oregon State University is that this wall has superior seismic strength to a wall where the sheathing is nailed directly to the studs. In fact, when this wall was tested under load, under the load that it would be if it was a first-story wall on a two-story house, they literally could not break the wall. They were able to displace the top plate 6 inches from the bottom plate without having the wall fail. So there's a good bit more exploration going on with that in our market, and some of the leading contractors here have been working on this. They have had to get it approved through local code officials currently, but we're hoping to work with them in the near future to get sort of standard code compliance documentation built up and see more of this type of a wall system be utilized. So one thing it does require is nailing at a much tighter pattern than a typical wall system would have. But as you can see, we have a few resources for you here about this, and we'll be keeping our friends in California up to date on things that on this type of system as we get more development about it. So the next section, we're going to talk about what moisture management looks like, in particular with these wall systems that we're talking about here.
David, would you mind if I interrupted you just to touch base on a few questions that came in during the previous session or the previous section?
Sure, that sounds great.
Okay, I'll do that. So we had a question about, I think you touched on it, but maybe you can recap options for achieving the prescriptive requirement without exterior insulation. So you mentioned the double stud and the staggered stud.
Yeah, I mean so to get to that U value, doing a staggered stud or a double stud wall are your best bets for reaching it. It is not a recommended solution to try to put foam on the inside of a wall system, because then you would be creating a moisture problem more than likely inside the wall cavities. And the difference between double stud walls and staggered studs is that with the staggered stud, you're typically just using a single bottom plate and top plate, of 2x8. 2x8 staggered stud would meet your requirement in California. But if somebody wanted to go further, they could use a 2x10 as the plate material. The double stud, then you start talking about having two different walls that you frame independently and stand up independently.
Thank you. And we have one other question I think we'll take right now, which is about structural support. So I guess this is a concern about using 24-inch on center, resulting in having a warp gyp board. Have you seen that before, or is there concern about that?
Yeah, I mean, I'll say when I started doing 24 inches on center back in the mid-90s, there was definitely a concern about that. But controlled CD board, if you're going to use half-inch board, CD board, controlled density board, is a stiffer board that you can specify for your projects, or you can specify a 5/8 board, and either one of those is going to be a more rigid board for the project. But I'll say, a 2x6 wall that's nailed into the sheathing is much less likely to have any kind of warping on the interior surface than the staggered stud or the double stud walls, because there you do have the interior studs are independent. I will say I actually live in a house that has the double studs, and my walls are pretty nice and flat, but that probably has to do more with the quality of the framing to not to really throw out bad studs in the first place. So that
Great
goes into
answer.
the
Yeah. um, and actually, there was a follow-up question to that first one, which was just if you can discuss performance-based solutions that achieve the prescriptive results, kind of the offset for this wall requirement.
Well, I mean, if your overall performance path can take into account other elements of the building, if you can reach it for through an overall performance path. What you're going to see though is if you don't have walls that are performing well, it's going to be hard to make up the difference in other parts of your building. So your attics are already getting better, so it's going to be hard to get enough of an incremental benefit there to make up for not improving your walls. Probably the best place you'd get that would be if you actually had fewer windows in your wall, and then you could have walls that were at a lower performance, but if you had a lower number of windows, that would help a performance path get there. Or you could move to some sort of really high efficient window system, and that would improve your overall wall performance when the windows are taken into consideration in the performance path. There is one other detail that has come up here in the Northwest over time, and I think will probably come up for you there, is the usage of blown-in batts for blowing in the insulation in the 2x6 cavities. When I brought up the fact that if you have poorly installed 2x6 batts, then you're not getting the real benefit of moving from 2x4 batts to 2x6 batts. So one thing we've seen to sort of ensure that quality for the 2x6 batt insulation is actually not to install batts, and instead to go to a blown-in bib system on walls, where basically you always get a superior installation quality. And now we've seen that through the programs across the Northwest, where they consider a blown-in batt in a 2x6 wall to perform at R23 and not at R21. And I think that's something to work towards in your market as well.
Great. So I'll let you proceed with moisture management now.
Yeah, let's do our quick little second polling question.
Sure.
Before I jump in, and then we'll get going with that.
Great. So the question is, and David, you won't be able to see this, but I'll read it out. Do you have your homes tested for air leakage? If so, why? And the options are A, no, B, to improve energy efficiency, and C, to prevent condensation inside wall assemblies. So sorry, you may like to select multiple options, but you just get one. So you can pick your favorite one. And I'll just let a few more votes come in. And I will close it out. And David, I'll let you guess what you think folks are responding to this question.
Well, I'm guessing most people are doing it for energy efficiency, if they're doing it.
Yep. So 33% said no, and 61% said to improve efficiency, and then we had 7% to prevent condensation inside the wall assembly. So okay. There's the shared results for everyone to see, except for David, can't see them. But
all right, well, thanks for doing that. It's great to know that some folks are doing it for moisture, most are doing it for energy, and a third of the folks here haven't been doing it at all yet. So one thing you might ask is, why in the world are folks in California concerned about the moisture in the walls anyway, when you have such a nice climate down there? But there is a changing climate, and some of the models are showing a real change in what's expected weather-wise, and so there's a few lessons we might be able to hand from long experience with having issues with water inside our walls up here in the Northwest. And so we don't have very much time to talk about this today. In fact, this is something we usually talk about over a 2-day period. But the high points we'll just go through here. A wall with higher R value becomes more vulnerable to condensation because they're better at blocking the heat from the inside of your house to actually getting to the outside of the house in those wintertime months. So that makes the exterior parts of your wall assembly potentially colder. And if any moisture does get inside your walls, now it's more likely to condense on your wall sheathing and turn into liquid and saturate the wall sheathing and even back into the framing materials themselves. So, we all know it's crucial to keep your walls dry from bulk moisture from the outside, but it's also just as important to keep them dry from moisture from the inside of the building getting to them. So, on the exterior bulk water management, flashing of all penetrations and having that really align and attach to the weather-resistant barrier for the building is extremely, extremely key, especially with the state of current roof design that you see on a lot of homes. That leads to a lot of flashings, and making sure that those are all done properly with proper kickouts is just very, very important. And the bond break that we're talking about here at a minimum, so your weather-resistant barrier is not coated with stucco, is just one detail that's really important. Another one that has really shown up in markets such as ours with a lot of rain, and then down in the southeastern United States, is if you do get saturated siding materials, then when the sun does shine on them later, you can get a solar vapor drive that actually, as it removes the moisture from the siding material, creates a lot of pressure, and that pressure can actually push the vapor back into the building assembly. So having a drainage gap between your siding material and your building is one way that alleviates that pressure and can stop moisture that might have come down on the exterior of your building as rain, saturated the material, prevents that from then turning into a vapor and being pushed through the skin of your building. Building Science Corporation has done a lot of studies on that, and we've developed putting in drainage gaps for that reason. In fact, drainage gaps are actually part of our code here in Oregon as a result of this type of research. This slide is showing us a few different materials that you can use to develop a drainage gap between your siding material and your weather-resistant barrier for the building. The design of all these different ones is basically to create an air gap. So when you do have moisture trying to be driven out of your siding material, it has an escape path for the pressure, so that it doesn't get driven into the structural building materials. There's a link here on the bottom that gives you some details around on stucco installation, which I would encourage you to read. As an aside, I'll just tell you, basically from the California border all the way through Vancouver, BC, you're no longer allowed to put synthetic stucco on projects up here because they had, not that you couldn't do it right, but it's been done wrong so many times in an area that has a lot of bulk moisture coming into it from the outside. The insurance companies just don't trust it anymore. And as a builder, your standard policy won't even allow you to remodel a building that has that type of stucco assembly anymore. You have to get a special rider just to do that. So these details are very important. because of those issues here, there's been a lot more movement on our walls, and as I mentioned, we moved to 2x6 insulation over 20 years ago, of creating this type of a vented rain screen for a system, and that has meant moving your siding, in this case clapboards, out over the top of a set of furring strips in order to allow a path for air behind that. And as you can see in the details, it even includes a screening element at the bottom. The clapboards themselves breathe in this type of a system, so not all of these have a screened exit at the top, but some systems actually also put in a vented screen at the top of the wall assembly to allow a full path for air to move all the way from the bottom to the top. And also it does provide a clearer path for bulk moisture to drain from the top down. Now that was all about bulk moisture from the outside. It is very important also, as I mentioned before, to keep the moisture that's in the air inside your building from coming into your assemblies, traveling through the wall and getting to your sheathing and condensing. So most people, when they think about how moisture that's in the air inside the home, how it might get into the wall, they tend to think of what this slide is showing, that the moisture could diffuse through the wall and first saturate the paint, the gypsum, and then come out the other side. But what's been shown in our type of climates, which are relatively moderate, and most of the time inside the home there's not a great vapor drive pushing this, over the course of a year, you're talking about only 1/3 of a quart of water moving through a wall assembly like this. Versus if you have holes in that wall, it doesn't take a very big hole, but if you have a hole in your wall assembly, in this case we're saying a 1-inch square hole in a 4x8 sheet of gypsum, that represents 90 times the amount of water that is going to be transported through that wall assembly and delivered potentially to the back side of your wall sheathing. And the conditions are given here, which are not extreme conditions. If the inside temperature of your building is 70 degrees and it has a 40% relative humidity, those are not extreme conditions inside a building. That's a pretty typical condition inside a building. But what this is really showing you is that it's a great idea to prevent air from leaving the inside of your building and traveling through your wall assemblies, because when it leaves the inside of your house and travels through your wall assemblies, it can carry a lot of water with it, and more than likely it will drop that water off at the sheathing because of how cold the sheathing is going to be in the wintertime, and it'll lead to this type of condensation.
And I have a question for you on this slide. Does the thickness of the drywall make a difference in this kind of how you see this play out?
Not really. Standard drywall, no, because standard drywall is very permeable material. We have a slide on that that shows the relative permeability of different materials coming up. So the drywall in and of itself, on the diffusion part, it's very permeable, so that doesn't really matter. And then in terms of how big the hole is, if you cut a 1-inch square hole through a 1/2-inch sheet of drywall or a 5/8 sheet of drywall, it's still a 1-inch hole through there. And if you think I don't poke 1-inch holes through my sheets of drywall, well, you probably don't. But imagine how much it adds up at the bottom edge of your sheet of drywall, where that attaches to your bottom plate, around every electrical outlet in your home. These things really, really add up, and it's unbelievable how much air can actually move through if you don't have a good air barrier detail built into your assembly. So, and you're not, even if you do detail it right, if you don't test to know how tight your building envelope is, you could still have holes because somebody like an electrician or a low voltage contractor, stereo system, alarm, something like that, can come around later and poke holes after you thought you've got it all detailed. And just one of those holes can lead to a real moisture problem down the road.
We actually have a few questions on this slide, so I might just hold you for a minute. So would you mind just explaining a few examples of ways that folks could be insulating those holes, like for example with the thermostat also, if that's being installed?
So the most important thing is to have a plan about where you are going to stop air from moving through your walls, because the air will be drawn into this wall if there is a hole in the drywall, only if there's a hole on the other side, either at the top plate or at the sheathing, that is going to be basically creating the draw to pull the air through. So your solution at stopping the air from moving through, maybe if you're going to try an airtight drywall approach, might be to use caulk on holes that are smaller than 1/4 of an inch, or spray foam if the holes are larger than 1/4 an inch, and try to tighten up your drywall. And with that approach, you actually should be caulking the sheets of drywall to your framing as they are put on the building. Or at a minimum, caulk the bottom edge of drywall to the bottom plate, and then use either caulking or foam gasketing at the top of your drywall sheets. And then that will stop vertical movement at the drywall. But the way folks who are really building tight buildings are doing it is they actually turn the wall sheathing into the air barrier, and they're using tapes, very, very sticky tapes, and taping the exterior of the wall assembly and sealing that, and that's where they're stopping the air movement. Because if it doesn't leave the other side, it's not going to get pulled in this side.
Mm. And one more question, just a clarification on the image. What is the time frame of the leakage?
Annual.
Annual. Okay, thanks. And so we have a few other questions, but I think we'll hold them until we pause.
Yeah, I want to make sure we hit all our topics here as well. So if moisture does get into your wall, it is really important that the moisture can get out. And everyone should always be building their wall assemblies thinking that at some point in time, some moisture probably will get in, whether it's from a storm event with a window that leaks, because basically every window will leak at some point in time, or whether it's from the fact that somebody else put the hole in the drywall long after you finished with the project. But that's why it's good to know what your assemblies are made up of. And a best practice is for your wall assembly to be vapor permeable in both directions, as this indicates. So that if moisture is trapped inside your wall, now you could trust on the diffusion that we were just talking about, which is not a fast or a strong force to move moisture, but it will allow moisture out. Make sure that you have a vapor permeable assembly so that if the drying potential is to the outside, it can get to the outside, or if the drying potential is to the inside, it can get to the inside. And that condition changes over the course of the year. So one thing we're just pointing out is on the exterior, if you're using exterior foam, being careful about what type of foam you're using. Some foams are more permeable than others, meaning they will allow vapor to move through them easier than other foams will. And again, we have a chart that shows that in a couple slides here. But for instance, if you use extruded foam on the outside of your building, that is not vapor permeable, so you really need to make sure that the interior of your building is permeable. So a worst case scenario would be if you were to do a PVA primer on the inside, creating a relatively impermeable interior, and using extruded on the outside, now you've created a wall system that will have difficulty removing moisture to either side. So this chart does show the relative permeability of different materials. So on the top are things that are very impermeable, and up there obviously something like glass falls up there, but also foil-faced polyiso rigid insulation falls there. It has that impermeable layer applied to the surface of the foam. You can actually get polyiso that has been perforated, so to increase its permeability. And as you move down, you can see that what I just mentioned, extruded polystyrene, falls into something that is still, it's semi-impermeable, but typically it's when you reach a perm rating of 1 or more that you start talking about something as actually being a permeable material. And now you're actually falling into, expanded polystyrene falls into this. Old-fashioned building paper is here, plywood, OSB, and when you get to very permeable materials, now you're talking about modern-day house wraps, some very permeable latex paints, the cellulose insulation, very permeable, the gypsum board, like you mentioned, Shannon, very permeable materials. So it's just understanding how moisture moves through walls is really, really important. We did throw one slide in here about a smart vapor retarder. So this is an example of putting up an interior material that you might use within your air barrier system. So if you remember the days when folks were putting up visqueen or a polyethylene plastic on the inside of their studs, the idea was that would help with air tightness and block moisture flow through it. You don't see that really applied much anymore because it typically was not installed in an airtight fashion, and it would allow air movement into the wall, but then it wouldn't allow diffusion out of it. The smart vapor retarders that are out there now, you can install on the inside face of your studs to block moisture from going in. But if a high relative humidity or saturation takes place inside the wall, they will actually, at the molecular level, open up and allow the moisture to release back out. So that's why they're called a smart vapor retarder. Versus these materials, like I said, old-fashioned tar paper and plywood, by their nature, they become a higher permeability as they get saturated. So by utilizing, say, plywood within your assembly, or understanding this with, say, cellulose insulation, those materials, as they get wet, they become more permeable. So within your design of how to handle moisture, you can take advantage of those intrinsic properties that they have. So I know, Shannon, we're running close on time. We have this cost study to go over, so I think we should probably go through that and then maybe take all the questions at the end.
I agree. Yeah, and we can stay on for a few minutes after and take more questions at the end if folks want to stay on too.
Great. All right. Well, there's not many slides here for this, so I think we're still doing well. As I mentioned at the beginning, we just wanted to share some recent information that had come out from reviewing different wall systems that were being utilized. So, by recent, this study was actually done in 2010, and it was conducted by Building Science Corporation and also local contractor here, Walsh Construction, that does a lot of multifamily construction and also some single family. So they studied 14 different high-performance wall assemblies and evaluated their performance, durability characteristics by looking at the drying potential. And then they also looked at what the cost considerations would be for each one of these different wall types. And looking at information from that study, they're looking at total dollars per square foot of wall, and so they're getting into labor costs, material costs for all the different elements of the wall systems. And what they were showing from their analysis is the most cost-effective system, once you start doing something more than a 2x6, was doing a 2x6 with 1 inch of extruded polystyrene on the outside of the wall. So, and then, just, let's see, read that a little closer there. Yeah. So it was very close between 2 different types of exterior insulation. I think we just mislabeled between 3 and 4 what the type of exterior insulation used to get the equivalent thing between the 792 per square foot and the 885 per square foot is really 2 different types of insulation used between option 3 and 4. Other than that, everything was relatively the same. And XPS is what's called out, in this, but a polyiso would give you a similar or better R value per inch. And if you were to move to an expanded polystyrene, your costs would actually be lower on the foam, but your costs for detailing at the openings would actually go up even more because you have a greater thickness to deal with there. You can see from their analysis, if they moved up to something like 4 inches of exterior foam, that was really a big cost driver for them in their analysis, using the type of sidings and exterior finishes that are typical on the jobs they do. The whole more complete analysis of all the different 15 assemblies that they did is represented here. And again, this report is available from Building Science Corporation. There also are additional resources I've listed on this slide that you can find very helpful. Some from PG&E's Pacific Energy Center, Building America program from DOE has some useful information. And the bottom one, Hammer in Hand, they're actually a local passive house contractor in the Northwest, and they've created some very detailed spec drawings that they've been good enough to share with the broader community. So that's the end of the materials. We have time for questions. We did have one other polling question. I'm not sure, Shannon, if you want to do that right now or save that.
Let's just launch into it really quick. I don't think it'll take very long. And then we'll stay on for questions, like I said, and we will be sharing the slide deck with everyone afterwards. One other thing, if you have to drop off early, we do have a survey at the end where you can give feedback on the webinar and share any other ideas that for future webinars. So please take a minute to fill that out as well. So here's the last poll question. Now that you've attended this webinar, what do you think are the biggest challenge is the biggest challenge to meeting the 2016 wall assembly standards? A, expensive materials. B, contractor experience with 2x6 framing. C, contractor experience with exterior rigid insulation. D, structural calculations required for 2x6 framing. Or E, spatial challenges, i.e. Property lines. It looks like it cut off, but in interior condition dealing with the increased insulation space. So letting folks answer that.
I already have my guess about which is going to be the most popular one here.
Oh, I can't wait. Okay, I'm going to close it out. Thanks to everyone who voted. What would you like to guess, David?
Well, having been a contractor for 15 years, I'm going to guess expense is number 1.
Wrong.
No way. Okay.
By a very close margin, the winner was contractor experience with exterior rigid insulation. If you have other things that you would like to chime in with, this is to the audience of challenges. Feel free to enter that in the questions bar. The second most popular was expensive materials
Okay.
And then contractor experience with 2x6 framing and spatial challenges tied with 7% each.
Okay.
So let me look at some of our questions. I have one going back to moisture management.
Sure.
If foam is over the studs with OSB or plywood on the outside, is there more chance of moisture issues because the shear is cold?
There's less, in that case, it is very unlikely the sheathing will dry to the inside of the building ever because you'll have that foam there. So in that case, you really need to make sure the sheathing can dry to the exterior. So it is highly recommended with that assembly that there is a rain screen siding on the outside. So say you're going to do clapboards there, you would put furring strips up first, create a ventilation cavity there. So if the sheathing did get wet, it can dry to the outside.
Great. Someone else pointed out another challenge, which is just maybe not as much experience, that the energy consultants themselves might not have as much experience in designing these assemblies. In that case, I would chime in and say that the programs, California Multifamily New Homes and California Advanced Homes, we work really closely with energy consultants. So if this is something that you're interested in trying now before the code goes into effect, you can give us a holler and we're happy to give some design feedback. I'm sure David would be happy to give some feedback too. So that's my answer to that question.
And trying to get a builder to test it, maybe before the code goes into effect, testing it on some of their houses first is a good way to go, right? Before they move it into full production.
So I do have one question about, it's not necessarily meeting the code, but just approaches for installing this technology on existing homes. So I'm sure there's other folks on who are doing retrofit work. What's your, I guess, could you quickly summarize some advice for avoiding moisture issues when trying to add on additional exterior rigid?
Onto an existing building?
Correct.
Well, the key for in most of those installations is determining where you're going to put your weather-resistant barrier. Are you going to put it behind the foam or on the face of the foam? And that gets complicated by basically what are you going to be doing at your openings, and typically that's doors and windows. But some contractors feel the best route is to put that weather-resistant barrier outside of the exterior foam, and that means figuring out how they're going to wrap that into the flanges of windows, or if the windows don't have flanges, how that takes place. But that gets, others think the best way is to put it behind the foam. So that, in my mind, is the biggest key for you, determining what you think the best path forward is about where you want to put the weather-resistant barrier, and making sure you've detailed all the intersections of that before you actually get there in the field, because you don't want to have to figure it out on top of the 24-foot ladder at the last second.
Great. So I'm just looking over some new questions. One second. This question is interesting. It's kind of more related to California policy. So you can defer to respond later, but let's see. So in order to take credit for all of these new wall assemblies, the CEC needs to, so the California Energy Commission needs to include the assembly options in the modeling software and reference appendices otherwise they won't be able to, the postulation is otherwise they won't be able to claim credit for these assemblies. Would you like to answer that question?
Well, I'm definitely going to defer that back to the California High Performance
Yeah,
or
I figured.
program, because that I believe you guys will be working on that,
Yes.
And working with the CEC to make sure these wall assemblies get put into the library. Yep.
Yep. We can respond to that question in our follow-up email as well. I'll tap into Matt Christie, who is the CAHP program manager. So, oh, Matt's typing to me. He says double walls and staggered walls are somewhat possible, but you kind of have to hack them. We'll follow up in more detail. I think we're at 106. You're welcome to enter more questions to us via email, but I'm ready to wrap up if you are, David.
Yeah, I appreciate having the chance to talk to everybody about high performance walls, and yeah, look forward to seeing this get built. I mean, the way I always looked at it is this was the frontier that needed to be conquered, starting back in the 90s, and now it's really coming to fruition. So I think it's great.
Well, thanks for presenting. We've already had a few folks chime in and say that they really valued the presentation. And like I said earlier, if anyone is wanting more advice on how to install and model these building systems, these assemblies, please email us at either of those emails that's on the screen now, and I'll be actually sending an email to everyone. After the presentation, the programs are available just exactly for this kind of support. So we look forward to working with you. Have a great rest of your day. Okay, bye everybody. Thanks, David.
Thank you. Bye-bye.